Hello, everybody. I'm Roman Rodriguez, and we are on Chapter 6 Equilibrium. This is for Physics Grade 9 and 10. Right, so let's begin. Now, before I go into detail about equilibrium, let me just brief you about torque. Now, torque is the turning effect of a body. In other words, we can say that it is a twist or turning force of an object. Now, mathematically, torque can be calculated as force times displacement. So the unit of force is Newton and displacement is meter. So we can say the unit of torque as Newton meter in SI units. Now, tau is represented as by Greek letter tau, and you can see the symbol on the slide. So remember that force and displacement, they are both vector quantities, and torque too is a vector quantity. And vector, you know the properties of vector, that it needs to have magnitude and direction. So torque has both magnitude as well as direction. So it is a vector quantity. Now let's move on to equilibrium. Now equilibrium means that the total net force acting on an object, if it is zero, then we say that the body is in equilibrium. Now, not necessarily that a body is in a state of rest is in equilibrium, but even if it's in motion, it could be in equilibrium provided the acceleration is zero. It is moving at a constant velocity. So remember that equilibrium, a body is said to be in equilibrium when the net force acting on it is zero and the acceleration is also zero meter per second square. Now there are two kinds of equilibrium, as you can see from the definition itself. One when the body is at rest and the other in motion, constant with constant velocity. So we call the two kinds of equilibrium as dynamic equilibrium and static equilibrium. Okay, static equilibrium is when the bodies are at a state of rest and the net force acting on that body is zero. And dynamic equilibrium, when the body is moving with a constant velocity, so the acceleration is zero. So these are the two kinds of equilibrium that we have: dynamic and static equilibrium. Now let's move on to the various states of equilibrium. Now there are three states of equilibrium: stable, unstable, and neutral equilibrium. So I will be discussing each state one by one. First, move on to the stable equilibrium. Stable equilibrium is when the center of gravity is at its lowest position, which means that when a body is tilted, its center of gravity rises and it returns to a stable equilibrium as long as the center of gravity acts to the base of the body. Now, this is an example of stable equilibrium, that when the center of gravity is uh, lowest in its lowest position. Okay, so example of stable equilibrium is the chair lying on the floor, the heavy base of the vehicle, table lying on the ground, cone lying on its base by lowering its center of gravity, and bottle lying on its base as well. Okay, because you know the base is wide or broad, and the reason for that is because the center of gravity is low, and you can see the Formula One car when it is moving at a high speed, it is low in height and its width is more for this very reason. So we can say that why the base of the vehicle is kept low, wide, and heavy. Now, you know, the bus also, the luggage compartment is kept on the base, and the passengers seated upstairs is not loaded on top of the bus, because it becomes heavy, and then there are chances of the vehicle being tilted or moved. So the lower center of gravity keeps it stable, and moreover, the base of the vehicle is made wide so that the vertical line passing through the center of gravity should not get out of its base during a turn. And even if you look into, in some countries, they have the double decker buses. So the lower deck is filled first, and then the passengers are told to move on top. Okay, that's how the center of gravity is lower and it's heavy. Okay, let's move on to unstable equilibrium. If a body does not return to its previous position when it sets free after slightest tilt, it is said to be an unstable equilibrium. Unstable state, as you can see, pencil like which is kept on tip or something, its center of gravity is at its highest position, and in this state of unstable equilibrium, as the body topples, from the base of the tip being narrow, its center of gravity moves towards its lowest position and does not return to its previous position. Okay, so that is an example of unstable equilibrium. And neutral equilibrium, if the body remains in its new position, but when disturbed from its previous position, it is said to be in the state of neutral equilibrium. Neutral equilibrium state is like, for example, a ball placed on the horizontal surface. When you roll the ball over the surface and leave it after displacing it from its previous position, it remains in the new position and does not return to its previous position. This is called neutral equilibrium. Okay. Uh, in examples of neutral equilibrium, you can see that the ball, just give you the example, moving on the ground, motion of sphere, roller, pencil lying horizontally. Okay, when it is lying vertically, it is unstable, but horizontally, it is neutral. And egg lying horizontally on a flat surface. Okay, these are all examples of equilibrium. So, in this chapter, we have covered uh, the topic so far: equilibrium, torque, kinds of equilibrium, and states of equilibrium. In my next topic, I'll be discussing about conditions of equilibrium and center of gravity in detail. So, hope to see you then. Take care.